Hello, this is Mrs. Hickman. Today we're going to be talking about the derivative of a function, and we're going to find it using the definition of a derivative. So, the definition of a derivative is that the derivative of f with respect to x is a function f whose value at x is this. So this looks like what you see at a slope at a point. So the derivative is the instantaneous rate of change at a point of x, provided the limit exists. So what we're talking about here, so in order for a derivative to exist, it must have a derivative and it must have a defined point. Defined point meaning it has an x and a y value. Okay, so it has to be continuous at a point and the limit has to exist. So if f has a derivative, it is called differentiable. Okay, don't forget that word because you will be continuing hearing it throughout the course of calculus. So if f has a derivative everywhere, it is a differentiable function. Okay, so the derivative is the slope of a tangent line at a point f of x. Okay, all right, so point meaning it has an x and a y value. So for the first problem, we're going to find the slope at y equals x squared plus 1 at 2, 5, and then we're going to find the equation of the tangent line at x equals 2. Okay, so notice this is just kind of extra information. We got all we need right here. But to start with, all we need to start with is x equals 2. So let's go ahead and find the slope. Also, the slope is a derivative. Just like you did in your rates of change, slope, another word for slope is derivative. Okay? So we're going to have f prime of x is going to equal the limit as h approaches 0 of f of 2 plus h because x equals 2 minus f of 2 over h. Now you could go ahead and find a derivative using this and then plug, put in like f prime of 2 at the end. That would work as well. So if you did it that way, you would end up with 2x. Okay, so let's get started. So f of 2 plus h, so that's going to be 2 plus h squared plus 1, okay, minus f of 2. So it's most likely going to be 5 because that's our y value. 2 squared plus 1 over h. Okay, square that by filling. Oh, don't forget to put the limit here. So you're going to have 4 plus 4h plus h squared. So that's the FOIL of that, plus 1 minus 4 plus 1 is 5. Okay, this is the part where things cancel. So you're going to have 4 plus 1 is 5, minus 5 is 0. So you're left with 4h plus h squared. You're going to go ahead and factor out the h. And then I'm going to go ahead and evaluate here. So that's going to be 4 plus 0, which is 4. So f prime of 2 equals 4. Okay? Again, if you decided to do x plus h minus f of x here, you would get so if you end up doing all the algebra here, you would end up getting f prime of x is going to equal 2x, and then you would plug your x value in here. Okay, so that's another way you could do that. Alright, so let's go to the second part of the question, which is find the equation of a tangent line. So to find the equation of a tangent line, you need a slope, which we got, which is 4, and a point. We also have our point of 2, 5 there. Okay, so point slope form, I do mine like this. Y equals m x minus x1 plus y1. Oops, that's supposed to be 4. So in slope-intercept form, it's going to be y equals 4x minus 8 plus 5. So your tangent line is going to be y equals 4x minus 3. Okay? And there you go. So that's how you find slope or the derivative, which is the slope, and the tangent line at a x value. Alright, let's do another example. Okay, so find the derivative of f. So we're going to find the derivative of this. So that's going to be the limit you're just looking at an x value. So the limit as h approaches 0 of f of x plus h minus f of x over h. So f of x plus h is going to be x plus h cubed. Okay. Minus x plus h. So that's the first part. Now we're going to subtract f of x minus x cubed minus x over h. Okay. So this is going to turn into limit as h approaches 0. So you have x plus h times x plus h times x plus h. You can do, I'm going to do x plus h times the FOIL of x plus h squared. So you're going to have x plus h, x squared plus 2xh plus h squared. Okay, now I'm at the distributed minus x minus h. And then right here, minus x cubed plus x. Okay, you can distribute here. There's another way you can do this using a box approach. I'm just going to do that up here. So if you have, so you're going to have like x, h, and then x squared plus 2xh plus h squared. Pretty much doing the same thing, distributing this term throughout, and then this term. It's just looking a different way here. So x times x is x cubed. X times 2xh is 2x squared h. X times h squared is xh squared. Now we're on h. X squared times h is x squared h. H times 2xh is 2xh squared. And then h times h squared is h cubed. So to write this as a polynomial, it's going to be x cubed. Your like terms are usually right here. X squared h plus 2x squared h is 3x squared h. 2xh squared plus xh squared is plus 3xh squared plus h cubed. Okay, and you'll be able to read it better right down here because I'm going to write it again. So you're going to have the limit as h approaches 0 of x cubed plus 3x squared h plus 3xh squared plus h cubed. Okay, that's this part right here. Now we're minus x minus h minus x cubed plus x all over h. And then we're going to go ahead and cancel out terms. X cubed minus x cubed, that's gone. 3x squared h, so that's not there. H cubed, we got negative x plus x. So you can go ahead and factor out h if you want to. So you're going to have the limit as h approaches 0 of 3x, well, I'm going to go ahead and factor out the h. 3x squared plus 3xh plus h squared minus 1. Okay, cancel out the h. You can go ahead and substitute in 0 for h. So you're going to have 3x squared minus 1 as the derivative. Okay, so now we're going to graph it. Alright, so we're going to graph f and f prime. So f prime, let's see, so f of x, I'm just going to find the zeros. That's going to be x times x squared minus 1. So it's going to have 3 zeros. X equals 0, negative 1, 1, and behavior, it's positive and odd, so it's going to be down on this end and then up on this end. If you don't know what I'm doing, just look at end behavior again. So it's going to start down here and end up there. Okay, looks something like that. Okay, and now we're going to graph the derivative, which is going to be 3x squared minus 1. Yeah, it's not going to look perfect, but you're going to see the slope of what it looks like of the whole graph. So 3x squared minus 1, here's minus 1. I'm just going to draw it like this. Okay, so that is graphing the derivative of a function. All right, find the line tangent and normal to, well, let me let you see everything at once. Here you go. Okay, so find the line tangent and normal. So same thing at x equals 4. Except we're going to have the limit as h approaches 0 of f of 4 plus h minus f of 4 over h. Where you see x, you're going to put 4 plus h. Okay, there's my f of 4 plus h minus f of 4 over h. So I'm going to have the limit, let's go down here, the limit as h approaches 0 of the square root of 4 plus h minus 2 over h. Okay, well now what? Now you're stuck. Okay, you can't go ahead and put that in here because you're going to get a 0. So what you're going to do is multiply by the conjugate. So the conjugate is going to be the square root of 4 plus h plus 2. Oopsie. Okay, now if you see, this is a difference of squares. This is a minus b times a plus b. So you're going to have the limit as h approaches 0, 4 plus h squared minus 2 squared over h times the square root of 4 plus h plus 2. Do not distribute that because that h is going to cancel here soon. So that's going to be the limit as h approaches 0 of 4 plus h minus 4 over h times the square root of 4 plus h plus 2. So as you're going to see, 4 minus 4 is 0, so you're going to be crossing out this. That's gone. That's gone. So you got the limit as h approaches 0 of 1 over the square root of 4 plus h plus 2. Substitute it in. So you're going to have 1 over the square root of 4 plus 0 plus 2. So that's going to give you 1 over 2 plus 2. So f prime of 4, so the slope, which is going to be the f prime derivative at x equals 4, is going to be 1 over 4. So that's how you find the slope. Now you are looking for the tangent and normal line. So to find the tangent line and normal line, you need a slope and a point. So we have the slope, we have the x value. So to find y, you're going to do f of 4. So x is 4. And there you go. So you're going to have 4 square root of 4. So your point is going to be 4, 2. Now tangent line. M equals 1/4 x minus 4 plus 2 is going to be 1/4 x minus 1 plus 2, which is going to be 1/4 x plus 1. That's your tangent line. Your normal line is going to be the opposite reciprocal slope. Normal line is just perpendicular. So you're going to have the slope is going to equal -4. So y is going to equal -4 times x minus 4 plus 2. So -4x plus 16 plus 2 is going to be -4x plus 18. Okay, so again, this looks really similar to rates of change, finding instantaneous rate of change, because it is. The derivative is the instantaneous rate of change at a point. So there's the work. Okay, next we are going to other notations of a derivative. This is important. I'm going to be using this one a lot, y prime. dy, so this is just finding the derivative. So it says if it asks find dy over dx or find dy dx, that's just mean find a derivative. Okay, that's all it means. df dx, you're not going to see this one too much. It's going to be this one or that one, and of course the one that we've been seeing, f prime of x, will be the notations. Okay, so you're going to see this one, and that one. This one rarely, but it's good to know that that just means, hey, find the derivative. Okay, great. So now we're going to go to one-sided derivatives. So remember again, a function is differentiable. So differentiable means there has to be a limit and there has to be a defined point. Okay. So differentiable on a closed interval a to b if it has a derivative at every interior point of the interval, and if the limit on the left-hand side is going to be this and this exist at the endpoint. So you're going to be looking at the endpoints. So this concludes that the function has a two-sided derivative at a point if and only if the function's right and left-hand derivatives are defined and equal at a point. So your left and the right-hand derivatives need to equal to determine whether or not there's a derivative at a point. So using one-sided derivatives show that the function is going to be differentiable. Okay, so to determine which one is going to be on the left and right, this is going to be on the left of 0 because you got the left 0. So this is going to be 0 on the left. That's going to be 0 on the right. Okay, so you're going to have the limit as h approaches 0 on the left of f of 0 plus h Okay, so that is going to be 0 plus h squared minus 0 squared over, h. So that's going to give you h squared over h. Okay, so you're going to end up getting h okay, so your derivative at 0 is going to be 0. Now we're going to try this one. So the limit as h approaches 0 on the right hand side of f of 0 plus h minus f of 0. So now we're looking at 2x is going to be the limit as h approaches 0 of 2 times 0 plus h. So that's 0 plus h minus f of 0 of or h. So you're going to get the limit as h approaches 0 of 2h minus 0, so 2h over 2, h. Gone. So the limit as h approaches 0 of 2 is going to be 2. So that is going to then say, so this is going to conclude that this two-side derivative at a point 0 it's not going to be defined and equal at that point. So it's not defined. So it's not differentiable at 0. Because 0 does not equal 2, not differentiable. Okay, that's it. Please see RunWeb for your homework and have a great night.